This video is going to cover systems of equations, word problems. So the last couple videos in the last section talked about systems of equations by substitution, elimination, some three variable systems, stuff like that. This particular area is just word problems. We're solving the same kind of equations. We just have to write them now from words versus just giving them to us. So a couple different things that we need. First, again, the first things we're always going to do is read the problem. Okay, I'm not going to do that. You guys can do that as well. But once I read the problem, there's some key things that I need to look at and understand. And what I'm going to do is I'm going to kind of just put a box around them. So this person bought 2 different packages of tulips and then 12 bags of daffodils for a grand total of $252. So then this person bought 13 tulips, right? 4 daffodils for a total of $232. So my goal is to then find the cost of 1 tulips and 1 daffodils. So yes, I did kind of underline a lot of things, but those things are important to the problem. When I start to solve this, the first thing that I need to do is once I read the problem, after that, I need to write down what variables are standing for, okay? Basically what I mean is this. I can't just write down an equation, solve an equation for a variable that I wrote, and I get a number, okay? I need to explain what the variable stands for. Think of it as a book, right? You're reading a book and then you get to page 72 and one of the characters dies. But then you don't know who that character is because they only introduced that character on page 72. Okay? You have to introduce them earlier because then if a character dies and you know who they were, you know what they were about, maybe the reason they died or whatever it was. Okay? You can't just do that same thing here in a math word problem. So a couple different things. One is I'm going to assign variables. That's the first step. We're going to assign variables. What that means is we're going to choose 2 variables. I like to always use x and y. You can use whatever variables you choose as long as you assign what they mean. So in this case, x, I'm going to say are the tulips. Okay? And really, what am I actually finding? It's really the cost, right? So it's the cost of tulips. And my y value are daffodils. But again, we're talking about cost because we don't know the value of daffodils or the value of tulips. Now, according to my equations, or the equations that I'm going to write down, it says Stefan, whatever, it says, so it's 2 times the cost, which is 2x. So that gives you the total cost of the tulips. Now I'm adding it because when you have stuff that's being bought together, you're adding them together. And then how many daffodils? He bought 12, and then that's the variable y is going to be equal to 252. Okay? So 2 times the cost of the tulips plus 12 times the cost of the daffodils is equal to $252, the cost of all of it. So now Jill bought 13 packages of tulips plus 4 bags of daffodils for her grand total of $232. So now it looks as though it's a systems of equations because I have 2 of them. And how do I solve it? Well, substitution's probably not going to work out too well. I'm going to try to eliminate. So how am I going to eliminate? Let's multiply the bottom one by -4. By -3. Once I do that, you'll notice my y values will cancel. And then we'll be good to go. So I'm going to rewrite the first one again, so which is 2x plus 12y equals 252. Now the second one is -39x minus 12y. That is why I multiplied by negative, so I can just add them together. And then 232 times -3, which is -696. Now I can add them together, so I get -37x. Y's are gone. 252 minus 696. which is negative 444. Now, in order to solve, I have to divide by negative 37, right? It's a one-step equation. And my answer is 12. So x equals 12. Well, what does x stand for? Remember at the beginning we assigned what it meant. So x stands for $12 for each tulip package, okay? So now what do I have to do? Well, I have to find the amount of daffodils. So I'm going to take the first equation that I wrote, which is 2x plus 12y equals 252. I'm going to plug the 12 into x plus the 12y equals 252. That's 24 plus 12y equals 252. I'm going to bring over the 24 by subtracting it. So that's 228. Then I'm going to divide by 12, and I get 19. So 19, we said, was the cost of a daffodil. So $19 for a daffodil bag. Now, on the last, again, problems we had, we wrote these as ordered pairs. Okay, I'm not going to write these as an ordered pair, like 12, 19. I'm not going to do that because it's a real-life problem. I need to find the individual value of these items. With 12, 19, that doesn't tell me anything. Because it's real world, I want units, I want values of what they actually stand for, not just an ordered pair. So this problem is then showing you how to find values of different items. So they could be pies, they could be cakes, they could be amount of people in a bus, or amount of people in a car, stuff like that. This problem right here will encompass all of them. It's the same work for all of the other types of problems where you're finding the value of items. So again, cost of cakes or pies, amount of people in a bus, things like that. This particular problem looks a lot more complicated because there's really only two numbers in the problem. Okay? So we're still got to make a systems of equations, but how do we do it in this particular equation or in this particular problem? So again, remember the first thing we said was you got to read it, right? So we got a boat and so on. We can all read that. So the next question is, remember we said earlier we have to assign variables. So I'm going to assign variables of certain items. Well, in the last one we had daffodils and tulips, so it told me what they were. In this particular instance, it says the speed of the boat in still water. So I'm going to say that x is speed of boat in still water, meaning if the boat is moving along and there's no current, whether it be with or against it, it's just moving, there's no current at all, that would be the speed of the boat. And then the speed of the current, that's our second thing we want to find. So speed of boat, speed of current. Now, how do we write two equations from what little information I'm given? The first sentence says traveling with the current a certain boat with 27 kilometers an hour. With the current means if I have the boat speed, and with means I'm going with it. So I'm adding in the current because I'm going with it. I'm going together, okay? So when I'm going with current, I'm going faster. So that's equal to 27 because that's how fast I'm going with both of those things at the same speed or the same instance. The second sentence is against the same current. So if I have my boat now and it goes against the current, that means I'm actually subtracting that value because I'm going slower. In this instance, my answer is 1. So I have my boat. Once I subtract the current, I'm going slower. Think about this. If you're a runner or if you've ever ran outside in the wind, if you're running and the wind is pushing you on your back, that means you actually run faster. I know it's a novel concept, but that's actually true. Or if you're running and you're running into the wind, that means the wind is coming into your face. Like, it's really hard to run as fast as you were running before. So that's where our information comes from. It's the same thing with a boat and the speed of the current. So I have a systems of equations. If I look here, my y's, if I add them, can automatically cancel. So 2x, when I add my x's, equals 28. X is 14 after I divide. Well, 14 what? Since x is 14, it's 14, kilometers per hour. That is the speed. That's how we measure the speed in this problem. Kilometers per hour. You need units on these values. Well, then I got to find my value of y. So let's use the first equation up here. 14 plus y equals 27. Y equals 13 because I subtracted the 14. So that 13 is the speed of the current because I said that's our value of y. Well, so it's 13 what? Kilometers per hour. This particular example involves two numbers. So like we did on the last couple, we got to write a system. Okay? In this particular instance, we have no idea what these numbers actually are, what they represent. So here's how I'm going to start this one. Again, we have to assign variables. I'm going to use x and y like I always do. You can use a and b, r and s, it doesn't matter. So two numbers. Well, two numbers, when I'm adding or subtracting, I'm always going to have a bigger and I'm always going to have a smaller number. Unless the numbers are exactly the same size, but then my difference would always be 0. So in this case, my difference is not 0, so we know I have two different size numbers. So x would always be the bigger number because we don't know what that number actually is. And therefore y is our smaller number. So the first sentence says the difference. Well, difference means subtraction. So if I take the bigger number and I subtract the smaller number, it's going to give me 3. The reason why I put bigger first as x instead of smaller is because if I were to leave it as x minus y, then I would get a negative number because it would be small minus big, and that's not acceptable. So make sure you always try to do bigger, smaller for x and then y. And then their sum is 21. Well, sum means addition. So if I add the two numbers, I get 21. Now let's figure out what we get. So I can add these because my y's will cancel. So that's 2x equals 24, x equals 12. So that means 12 is my bigger number. Now you might be asking, well, what are my units? There isn't any units on this particular instance because we're just finding numbers. We're not necessarily finding how the speed of something or the cost of something or how many people are here. It's just a number. So now I'm going to take this equation. You can very well take the top one. Doesn't really matter. 12 plus y equals 21. Y equals 9. So again, my y value is 9. So this is 12, this is 9. So 12 is the bigger number, of course it goes with our x. Y is the smaller number, and of course it goes with our y. This particular problem here, it looks as though there's a lot of information, which that is exactly accurate. So people are planning a pizza party and they have a whole bunch of different food and so on to bring. They have different choices to bring. So if I look at it, I don't have two unknowns like I did with the tulips and daffodils, or bigger and smaller numbers, or wind speed, or current speed and boat speed. I have three unknowns: pizzas, chips, and soda. So now because I have three unknowns, that means this is going to be a 3x3 system, so I'm going to have three different variables. So I have x, y, and z. They both stand for something. So I'm going to say because pizzas come first, let's say x is pizza. Because chips comes second, let's go with chips as y. And because soda comes third, let's go with that as z. You could use P, C, and S, or any combination of things, as long as you are writing it down. Now, this is pizza, chips, and soda, but really we're talking about cost, right? It's how much these items cost, so we need to make sure we understand that part about it. So the first part, it says 2 pizzas, 3 chips, 4 sodas for $33. Well, using the variables that we wrote, I can rewrite that as 2x plus 3y plus 4z equals 33. Now the 4z, some of you might be like, well, it says 2 liters. Well, 2 liter, remember soda, that's what it comes in. So the 2 there is just the amount of soda per container. The 4 is talking about how much of the containers you're actually buying. So this 2 doesn't really matter, okay? It just talks about, again, the quantity per container. So then the second part, it says 2 pizzas, 2 chips, and 6 2 liters for $32. So 2x plus 2y plus 6z is equal to 32. Now the third person thinks they should get 2 pizzas, 4 chips, 5 sodas for 37. So 2x plus 4y plus 5z equals 37. I would rather get more pizzas than chips, but that's just me, or even soda anyway. So if I look, I have a 3x3 system. In the last section we talked about how to solve these. I need to eliminate some variables. So what I'm going to do is I'm going to multiply the second one by a -1. That causes the x's to cancel with the top one and then the bottom one also as well. So let's rewrite the first one. So I'll use a different color here. So the first one is 2x plus 3y plus 4z equals 33. And then I'm going to rewrite the second one underneath after I multiply by a -1. Negative 2x minus 2y minus 6z equals negative 32. Now let's add those together. So that's 1y, because 3 minus 2 is 1, minus 2z, because negative 4 minus 6, equals 1. So that's good. Now I got one equation with no x's. Well, now I need another equation that I'm going to get at the end with no x's. So now let's do the second one. Let's rewrite it after I multiply by -1. So it's negative 2x minus 2y minus 6z equals negative 32. And I'm going to take the third equation and just write it right underneath. 2x plus 4y plus 5z equals 37. Again, you notice my x's are going to cancel. So let's cancel. This gives me 2y minus z equals 5. Okay, so now I have an equation here with no x, and I have an equation here with no x. So now let's solve that one. And I'll write that one. I'll write the green one right underneath the red one there. So that's 2y minus z equals 5. So which variable do you want to get rid of? Again, it's your choice. Let's get rid of the second one here, and let's multiply it by a -2. So that means I want to get rid of my z's. So let's rewrite the one in red. I get 1y minus 2z equals 1. And then I'm going to multiply by -2. So negative 4y plus 2z equals negative 10. So now if you notice, my z's will cancel. So I get negative 3y equals negative 9, y equals 3. So coming back with that 3, what does 3 mean? That means how much each chip costs. Well, 3 doesn't tell me anything because we're talking about dollars in this instance, so it's $3 for each bag of chips. So now I'm going to plug that 3 into, say, this equation here. So that's 3 minus 2z equals 1, negative 2z equals negative 2, z equals 1. Well, what does z stand for? Z stands for the cost of a soda. So we know the cost of a soda is $1. Now I need to find the amount of the cost per pizza. So let's use the first equation, and let's plug in the known values already, which is chips and soda, and then we're going to find the value of each pizza. So let's go all the way down here. So 2x plus 3 times each chip was 3, plus 4 times each soda was 1, equals 33. 2x plus 9 plus 4 equals 33. 2x plus 13 equals 33. 2x equals 20, and x equals 10. So what stands for 10? That is the cost per pizza. So I know the cost per pizza is $10, the cost per chips is $3, and the cost per soda is $1. You notice that was a lot of work. Well, that's just as much work as in the 3 variable systems that's already has the equations for you. We just now have to come up with them, the variables, we have to assign what they are, and then answer our questions. Again, make sure your answers are written with the correct units and not in ordered pairs or ordered triples, because it's a real world problem. This concludes solving systems of equations with word problems by using elimination or 3 variable systems or whatever method we had to use to solve them.